Hello and good morning, everyone. My name is Priyanka Shrestha and I'm the news editor here at Energy Live News. Welcome to this webinar about how businesses can capitalize from clean energy through on-site generation and how on-site energy centers could provide long-term cost and carbon savings as well for businesses. So today we have two experts from AMP Clean Energy. So first up, I'll introduce our first speaker. He's Mark Tarry, who's the Chief Financial Officer. If you could introduce yourself, please, Mark.
Good morning, everybody. I'm the CFO of AMP Clean Energy, and I head up the Urban Reserve business day to day.
Okay, thanks, Mark. And we also have Stuart Reid, who's the Managing Director for Projects. If you could do the same again, Stuart.
Good morning, everybody. Thank you very much for joining us. I'm Stuart Reid. I head up the project development team for AMP Clean Energy, and I've been involved in helping people look at on-site energy generation for about the past 10 years.
Okay, great. So before I hand it over to the speakers now to go through the presentation, I'd just like to go through a bit of housekeeping. So the webinar will run for a maximum of an hour. And in terms of the format, the speakers will go through their presentation one after the other, and we'll have a Q&A session at the end. So we've saved lots of time for that, so please do make sure you send in your questions. So the way you can do that if you haven't used BrightTalk before is there should be a Ask a Questions tab on your screen. So if you just click on that, ask your question, send it over, it'll come through to us, and like I said, our speakers will answer those at the end. Hopefully we'll try and get through as many as we can. Also, the webinar will be available for you to watch after the session is over, so after 12. So in case you miss anything, or if you'd like to share the webinar with your colleagues for any information, you'll be able to do so via the Energy Live News page through which you access to the webinar, or you'll also be able to do that through your BrightTalk account. Also, for your ease, we'll also be tweeting the link out at the end of the session, so you'll be able to access the webinar there. And finally, please do rate the webinar and leave us a comment as well at the end, because we'd love to know what you think. And also, if you have any suggestions as to future topics, that would be very helpful as well. So without further ado, I'll hand it over to our first speaker, Mark. Mark, over to you.
Brilliant. Thanks, Pri. By way of an introduction to AMP, AMP is a clean energy business. It's focused on biomass, waste heat recovery, and flexible generation. And we develop projects both in front and behind the meter and procure funding for our projects and our customers through our infrastructure fund, which is a vehicle that we call AMPL, or AMP Infrastructure Limited. I propose to start the presentation really with a helicopter view of the market, and to focus on four main drivers of disruption in the energy market as we see it, and to try and distill what the consequences of those drivers might be. And then I will pass on to Stuart, who will then focus and get more granular on the economics around on-site generation projects. So the first driver that we see really creating a lot of disruption in the market has been the rapid growth of renewables, which has had a huge impact on the supply mix, the generation mix. And to put that into perspective, wind and solar now account for in excess of 30 gigawatts of installed capacity, which is substantial when you compare it to winter peak demand of 50 gigawatts and summer peak demand of 30 gigawatts. And in all of National Grid's future energy scenarios, they anticipate continued deployment of renewables. And this is truly remarkable, the growth that we've seen. But it's the intermittent nature of renewables that is creating problems for the traditional marketplace. And it is that intermittency that is increasing the volatility that we see in imbalance prices, in peak power prices. And it's also reducing the load factors for traditional thermal generation plants that are, historically have been transmission connected and were built to run base load. And so the starting point for unpredictability, as far as we're concerned, is this continued growth of renewables. And we believe that this continued growth of renewables will require much greater system flexibility, both at transmission and at the distribution levels, in the form of more demand-side response, more storage, and increasing flexible generation at the distribution level. So that's our first driver. The second driver is the growth of demand, and that is being driven by the increased need for automation within industrial warehouses, increased data, and the prospect of electric vehicles and heat pumps. And I think, in one of National Grid's scenarios, they talk about 36 million EVs by 2040, which will potentially create substantial pressures on the network. And what we think is that these pressures will be experienced and will be localized. So we expect to see congestion or demand constraint hotspots in areas where population densities are greatest. And this will create real pressure for the distribution networks. And DNOs will either have to respond by spending more money on infrastructure, so more money on cable, on substations, on transformers, or they're going to have to procure flexibility services from the market, from third-party providers, developing assets and managing assets in flexible ways to provide capacity for DNOs when they need them most. Our third driver is often little talked about, and it's heat. And we would suggest that the decarbonising electricity has been relatively easy. Decarbonising heat will be much more challenging. Heat pumps, I think, have a role to play, and they have a role to play particularly within the domestic sector and decarbonising space and hot water within the domestic sector. But if you're a large industrial process heat user, you need high-grade, high-temperature heat for your manufacturing processes. A heat pump is not going to cut it. You're going to need something else. And we suspect the answer lies in on-site generation, in a combination of technologies which may include biomass for heat only or biomass CHP, gas CHP, and a much more efficient, better use of waste heat on site. And finally, underpinning all of these things is uncertainty surrounding policy and regulation in particular. So as we stand today, the CM market or the capacity market is suspended. Ofgem have basically brought to an end the residual component of triads for embedded generators, and the TCR proposes to remove the residual component of charges and change it from essentially a variable rate charge to a fixed charge, with implications for on-site generation and on-site demand users connecting in at 132 and 33 kV. There's also a strategic code review, an SECR underway, which will focus on use of system charges and grid access and the cost of grid access and the firmness of grid access. And of course, everyone's favourite subject, Brexit, at a time of increasing dependency on interconnectors. So in this world that we now find ourselves in, a post-subsidy world, rule changes and grid regulation are increasingly playing an impact on the direction of policy. So what are these drivers? What do they actually mean? We think that increasing uncertainty must increase risk premiums. We think that this will have to express itself in rising capacity market prices, and rising capacity market prices need to take effect if we are to see investment in new build flexibility. We also think that the increase in renewables will have the effect of creating two marketplaces. We'll see a market emerging for energy, and that will be dominated by renewables, and specifically because they rank at the, highest in the merit order because of their low marginal cost of production. And the second market being the market for flexibility. And again, we think that that market will manifest itself in the form of an ancillary service market or indeed through the capacity market itself. And finally, this increase in demand hotspots will lead to an increase in reinforcement costs at the D&O level, or the increased expenditure on third-party flexibility services. But in combination, our sort of conclusion is that staying grid connected will become increasingly more expensive, and the economics of on-site generation, particularly when combined with the ability to use heat more effectively, will become increasingly compelling, and Stuart will go through that. And these price rises, we've flipped to the next slide, but these price rises that we're seeing and the volatility that we expect to continue to see are very real. They're very real today, and we expect them to become more acute through time. So we've given a quick example of what happened during the Beast from the East, which most people know about last year, where in a 24-hour period, you can see prices were as high as 900, these are system prices, so the cash out imbalance price. Prices were as high as £990 a megawatt hour, and then within 24 hours, prices crashed and were as low as £142 a megawatt hour, negative £142 a megawatt hour, as wind farms were curtailed as there was too much power on the system and the system was long. And this can be seen, this trend of volatility can be seen over the course of the last 8 years, where the standard deviation of imbalance prices has more than doubled. So standard deviation being a sort of very basic measure of volatility. So, you know, intermittency is driving volatility, price volatility is real, and we think it's here to stay. So without further ado, let me, hopefully that sets the scene, and let me pass the baton on to Stuart, who is going to focus on what this all means for on-site generation.
Thank you, Mark. Good morning again, everybody. So, Mark, I think you've done a fantastic job there of outlining what we see as being the key drivers for change in the electricity market, and in particular how they'll begin to interact with heat. I'd like to focus on what this means for on-site generation and on-site projects. And I think there's a couple of tensions, as I see it, between the government direction of policy that we're seeing through things like the targeted charging review, the TCR, and some of the headlines that drives about the negative impact that will have on on-site generation, and these fundamental drivers you've outlined, where we genuinely think that over time it will cost more for energy and for being connected to the grid. So I'm hoping that you find this presentation interesting. We've commissioned some quite interesting work specifically on the TCR that I'm going to summarise for you today. But equally, that's just one facet of what is quite a complicated and quite a messy energy market. So the key challenge, or the key question I've challenged myself with today, is answering this one: is on-site generation still viable? And I think the thing that strikes me after having spent, as I said, about 10 years in this market, is just the sheer complexity of the energy space. So this slide is really a bit of fun, where we've kind of developed what we think of as a periodic table of energy market complexity, which basically looks at the huge number of 3-letter and 4- and 5-letter acronyms that are out there that basically govern your day-to-day jobs, trying to get your heads around what is energy, and where's the energy price going, what does that mean for your business, and how should you react to that. And it's, I think, almost an impossible task to understand what all these different drivers are doing, how they all interact, and what impact they're going to have on your business. And then to take all that and translate it into a decision about how you should advise your businesses to take forward their energy mix and their energy balance and any energy investment is pretty much a thankless task. And it's only really when I wrote these down that you start to truly understand the complexity that's around. So this is a little bit of fun, but it also highlights just the sheer complexity that we face around both the existing schemes and subsidies that are out there, the different elements that make up your energy bill, so the different costs and charges you face, the different policies that are emerging and what impact they're going to have, the huge array of different technology solutions you can deploy, and even we've categorized those ones in dark green as voltage, but really that's just kind of that's just an expression of energy values and connectivity. So you've got everything in there, and each site is individual. Your connection level is individual, whether that's EHV or HV or LV, and we've got, if that wasn't confusing enough, we've got to add in dynamics like HHV, which we think of as higher heating value and lower heating value and net calorific value. So really what this slide is doing is just articulating the vast array of complexity that's out there. So when you're developing, and my job is basically to help our customers understand what a fully funded energy scheme from AMP Clean Energy can do for them, and will that actually generate any financial savings for them or not. And the key message I have is that each business case is individual and each site needs a case-by-case assessment. So when you factor that in and overlay all this complexity on top of it, it creates a real difficult and challenging task to try and simplify this and help people understand what action they can actually take. So that's just sort of building on Mark's theme really of the complexity and the drivers that are in this space, and thinking about specifically what you must think about for an on-site project. So it's complicated, it's messy, and it's difficult. So what is a natural response in that situation? And really, what's a rational response to chaos? Often it's inertia. So we see a huge amount of people burying their heads in the sand in response to all this uncertainty and this complexity. And I think that's rational. I don't think it's the right thing to do, but it's a very understandable reaction. So our main challenge, or the main challenge we face, is not whether people do an on-site project using the AMP-funded solution or do one with self-funding. It's basically inertia, and it's the status quo. And that's understandable in the face of all this complexity. So what I thought would be helpful is to separate the world into a sort of series of what is simple and what is complex, because it's quite easy to lose sight of the open goals that are sitting there ready to be taken in the face of all this complexity. And the next table I'm going to show really tries to identify what projects we think are actually quite straightforward to pull a positive business case together on, and then identify which ones we think need a bit more assessment. So I'm then going to spend, once I've shown this table, I'm then going to go into a fair bit of detail on the complex ones, but I think an opening message from us is that there's actually some projects out there that are quite simple and are quite straightforward, and we would really recommend that people take advantage of those simple and straightforward ones where they are an option that's open to you. So I've called this business case viability and split it into just do these ones. So if they're simple, then my advice would be focus on them first and crack on with them. And the more complex ones, where we've said assess them, are the ones that you really need to spend a bit more time developing the business case on. So in terms of the simple ones, renewable heat has been a big focus of mine for the last 10 years. And I think that there's still a really strong business case to be had in the adoption of renewable heat. That renewable heat uptake in the UK today has predominantly been characterised by biomass, and there is still today a strong business case for the uptake of new biomass projects, and particularly for those clients that are off the gas grid. So if you have a site that is a big user of heat sitting off the gas grid, heated by either oil or LPG or electricity, then there's a very, very strong business case still available for the uptake of low carbon, whether that's biomass or heat pump related. So that's focus number one, is don't think that the renewable heat incentive days have passed. It's still very much alive and still very much active, and we've got 2 years to crack on and deliver more projects through that. The second area that we think is actually quite straightforward, I mean, conceptually it's straightforward, the actual project implementation is a bit trickier, but industrial heat recovery or waste heat recovery is such a strong and exciting story that I think it's quite easy for people to get the message. Basically, there's lots of heat in this country being wasted that could be put to good use, either as a heat source or as an electricity source. And this is an area we at AMP Clean Energy are very excited about, and I've got a team who are focused on that and have quite live discussions. So I'm actually going to spend a little bit of time later on talking about what that means in practice. For HV connected baseload customers, so we're thinking down at 11 kV level, if you have a decent heat demand, we think and believe that on-site CHP is still very much a viable option for you. And some of our analysis charting the impact of the TCR will demonstrate that. And the other areas that I think are still viable and still really exciting are for customers with the right load profile, so the right balance of electricity and heat, and sufficient enough volumes of heat demand. Gas turbines are still quite exciting, and I think that's quite a robust and resilient way to future-proof your site. We're now, as well, not quite today, but within the next couple of weeks, we're going to be into the era of subsidy-free solar, certainly for new projects that are being developed. We're quite excited about that. We have a solar fund. We're active out there targeting new projects. And in our heads anyway, the future for on-site solar is positive, and it's just going to be a bit bigger than has previously been the case. So we think that up around the 200 kilowatts level, for customers with a decent site demand, there's still going to be a really positive business case for that. And Mark has spent more time on battery storage than I have, but I think solar PV at around the 200 kilowatts, coupled with battery storage as the cost of that reduces, is going to be an interesting and viable space going forward. And really the key message around that is that's going to be that will be viable where people are offsetting their existing electricity bill rather than as a grid export play. And the final category that I think is quite straightforward is what I've called biomass with waste fuels. Now, waste can mean just offcuts of wood from a process. So, for example, we have 3 or 4 projects currently live and underway with customers who are sitting connected to the gas grid for their heat, but where we're able to reuse some waste wood that comes off their process, or recycled wood that comes off their process, and give them a cost saving against gas and all the carbon savings that are associated with that. So that's quite an interesting area, and equally at a bigger level for customers who have a more exotic or complicated waste process. I think there's a real opportunity for them to start to view waste as potential energy material and really benefit from cost and carbon savings there, and particularly when you start to think about the avoided cost from landfilling that waste.
So Stuart, what would you consider as an exotic waste material?
I suppose some good examples are things like maybe draff from distilleries, so byproducts of processes. So, you know, we even know of some gin producers who are using some of the botanical waste. Now that comes in small quantities, but it's just thinking more creatively about that type of off product from your process and utilising that more effectively. So I think anything's possible. And I think in the wider market, we'll probably start to see more exotic biomass fuels coming in as an alternative to existing sort of pellet or wood chip fuels. So that's the group of what I call simple projects. So if you fall into any of those categories, I'd say don't get sidetracked by the complexity. Crack on with them. Really get your teeth into them and get moving, and that's something we're delighted to help people with. And we are able to fund all of these solutions. So we do believe that these are good and viable projects. I think where it gets more complex, and what I'm now going to focus on is in some of these other categories. So how is the market looking for EHV customers? What does it look like for customers with climate change agreements or energy intensive industry exemptions? What does it look like if you don't have a heat demand for your CHP? And renewable heat generally on gas needs a little bit more thought. But don't let the level of detail that I'm about to go into around some of this stuff make it feel distract you from picking off the low-hanging fruit or really scoring those open goals that are available. So going into the complex ones then, and as I said, there has been quite a lot of adverse publicity about the TCR and the impact that's having on on-site generation. So has video killed the radio star? Has TCR killed on-site gas CHP? That's the question we're trying to address here. And this analysis does get a little bit geeky and technical, so apologies for that, but I do think there's some value in what we're actually demonstrating here. So the headline message about the TCR is that the impact of it's going to vary in different parts of the country. And when I first started looking at the TCR, I had it in my head that it took away basically all the costs associated with some of the grid connection costs, and actually that is not the case. So what we've done is we've looked at what the TCR impact is going to be like for 11 kV connected customers in different parts of the country and connected to different DNO areas. And the reality is it's quite different in different parts of the country. So what this map, I'm not going to dwell on this map, but basically what it shows is if you're in London, the TCR impact on a behind the meter project is actually quite small. So before TCR, and remember TCR is not going to be implemented for a few years, but before TCR you could offset about 40% of your costs with an on-site generation project. Post TCR in London, that's going to reduce to 36%. So the actual impact of TCR in London or that DNO area is actually relatively small. If you go up to Yorkshire, which is where we're going to spend a bit of time looking at, the impact of it starts to become more significant. So the level of cost you can offset from a behind the meter project reduces from 42% for this type of peak load customer down to 28%. So what we're going to go and focus on is what impact this has on that type of customer. So let's look at that then. So what we've done is we've highlighted what a current electrical spend is on a TCR customer or on a 1 megawatt baseload customer. So 1 megawatt electrical demand running 8,500 hours a year, 11 kV connected in Yorkshire. So this is about as granular as analysis gets. And currently, based on we've basically built a price stack. So currently, that customer would be spending around about £1.1 million a year on electricity generation. And that's made up of a range of costs, everything from the wholesale cost through the TNUOS, some DNO costs, some system use charges, the capacity market charges, and various levy costs. And the levy costs bucket captures things like CFD, FIT, ROC costs. So whole host of costs go in there. But you can see kind of headline message there is that the wholesale energy cost is typically about half the cost of that customer's bill. So what impact will TCR have on this customer? You can see the headline message is that it will actually reduce their costs. So TCR is good news in one sense for this customer. So if we were looking at that project today, prior to TCR, we'd be trying to identify what the potential savings were from a behind-the-meter project. And that spits out that chart. So what we're effectively doing is we're avoiding a lot of the grid costs and a lot of the levy costs for that customer by shifting generation on-site. So you can see that there's a pretty chunky green arrow there, and that green arrow represents the savings available. So the bit of analysis we've done is said, okay, let's build up this same price stack for this customer and look at that post-TCR. And this is where it becomes quite interesting. So you can see that the impact that the TCR is having is it's quite substantively reducing the potential savings on offer from a behind-the-meter project for this typical customer. And if I was to stop this webinar now, that would be quite a depressing message to end on, because, and this is really where the headline message around about the impact of TCR and behind-the-meter projects starts to emerge. So if we take this analysis at face value, what it's telling us is that the business case for a behind-the-meter project is actually a bit worse post-TCR than it is today. But I don't think it's right or appropriate to stop the message there. Really what you have to think about is a couple of things. And the first of those is what potential value does the capturing of heat have on that project. So typically in a gas engine you've got two sources of heat. You've got your low temperature heat recovery. So typically that's half the available heat or thereabouts in an engine. So if you start to factor the value of that heat being recovered, you can see that green arrow is getting bigger again. So we're starting to generate quite significant savings. And if we're able to do something clever with the exhaust heat, then you can see that green arrow gets even bigger. So I think the message really, the key message from this is that even if government policy review stopped at the implementation of the TCR and none of the drivers that Mark's outlined start to cause any additional costs in grid connectivity, then if you find the right site with the right heat load, CHP behind the meter remains a very viable option. So that's kind of key message number one in relation to the impact of TCR, is find the right site with the right heat demand. So ultimately, TCR is going to have an impact, but for the right type of client, the fundamental drivers for on-site generation remain the same. And where we've taken a little bit of a more exciting look at the future is we've thought a bit about the drivers that Mark talked about. How will they actually manifest themselves as future costs of electricity and energy spend on businesses in the future? And so I think the drivers are strong, and those drivers, as Mark outlined, will start to have to bite. And really, we're using the phrase increased capacity market supplier levy as really a proxy or a catch-all for the fact that the kind of grid costs are going to have to increase for end users. Now there'll be a bit of nuance about how these are actually brought in, and will that be on a volumetric basis or will it be on a capacity basis, but I suspect the direction of travel is going to be more volumetric for some of these additional costs than capacity. So if you start to really think about that, then what does that do? It means that you can't stop the clock just at the TCR being implemented. You have to start to think about these additional costs. So we've modelled three scenarios for that. The first is these costs being reflected at about £8.40 per megawatt. And what that does is increase the value of that green bar. If you speculate that actually those costs will go up to more like £25, then that green box is just getting higher. And if you think about £45, and Mark, I know that's a number that you've spent a bit of time thinking about, then really the behind the meter savings start to become good again.
So this is really an extension of the CM prices. So what we're saying is £8.40, that's the clearing price for the last contract. We think that is unsustainably low and is unlikely to generate new build capacity, certainly the kind of flexible capacity that we're going to require. There's a growing sort of coalescence around a price of £20 to £25 as to probably a more sustainable price. And then I think at £45 as a CM price, that's the sort of price that people talk about to build brand new CCGTs. Whether CCGTs are the right asset or not, I don't know, but certainly that's the price point that the market is talking about.
Yeah, and I think what we're really saying here is this is a bit of speculation, and what this speculation does is say all these drivers exist for the electricity sector, and they're going to have to somehow be charged and paid by the system. And really what you need to do is start thinking about these and how they impact. And then if you start to capture the value of heat, then it's kind of obvious that those potential savings just increase even further. So that sort of picks up TCR in a way that I hope is interesting and insightful. The other bit, I know there'll be a lot of people tuned into this who are sitting with climate change agreements, which mitigates the impact of CCL on their energy bills. And similarly, there'll be some people who are energy-intensive industry users, so with exemptions on some of the levy costs. So this, again, is an area that definitely you need to think about the impact of an on-site project on those costs. So the fundamental question is, of the electricity bill that you are currently paying today, what is offsettable by an on-site project? And really what we're saying, we've done some analysis in this, and what it shows is that the impact of CCL discounts and energy-intensive rebates is such that you basically chop about 25% plus off your kind of headline electricity price. So really, if you're thinking about behind-the-meter project and you're a customer with those sorts of exemptions, you know, and we as somebody who's trying to convince you of the merits of a funded solution, really understand that what we have to do is compare your real cost of electricity, not your headline cost. So we're kind of versed and understand the impacts that these have. And again, think about that in the same way. If you look at the impact of TCR for this types of customers, actually there's no saving available from a behind-the-meter project at this 11 kV connection. So what you have to do, and it's kind of logical again, is think a bit about the future value of this capacity market, and then think a bit about the value of recovering heat and using it on site. And once you start doing that, you basically start to generate significant savings, and that's what makes behind the meter viable. So if you are a user with an EII exemption, energy intensive industry, and a climate change agreement, then what we're concluding here is that you really must be using capturing significant chunks of that heat, or there's no point in a behind the meter project. And the next chart we've got is basically it's a different way of expressing the same thing. And what we try to do here is say, what is the break-even cost of avoidable electricity at different sizes of CHP solution? So really, it looks to us like, and this doesn't factor the capital cost of the equipment, but it looks to us like you need to be around about the 6.5 pence of avoidable electricity cost before a behind-the-meter CHP project is viable. Again, there's quite a lot of complexity and nuance goes into building up this chart, and it's something that you really have to assess on a case-by-case basis. But you know, we'd be happy to help anyone really review their sites and understand the implications of this and get a feel for where they sit on this chart. Final couple of slides from me, really. I just want to spend a bit of time talking about industrial heat recovery. I mentioned it early on, and really the high-level messaging around this is fantastic and exciting, and it's basically, why waste heat? Let's capture it and let's do something positive with it, and let's do something that reduces carbon and reduces costs. So some people know that BEIS have currently got a program that allows some support for industrial heat recovery. And the underlying analysis that justified that program identified that there's about 11 terawatt hours of wasted heat within the UK today that is recoverable, that is technically recoverable. And if we get our act together as a country and start to do this, then that can produce enough electricity to power 550,000 homes and save 500,000 tonnes a year of CO2. So there's huge potential benefits to doing this industrial heat recovery properly. We have a product on offer for really trying to deliver this in a funded way for people, and we think that it's really most suited at this point to customers that have 400-degree plus waste heat available. And where that is the case, then we're into the technology that we think is most viable and most attractive there is the use of an ORC to take that heat and generate electricity. And if we do that, you effectively get about 25% of the thermal waste heat as useful electricity, and it also means that you've got the other 75% as low temperature hot water that could be used for district heating or other uses on site. So yeah, waste heat recovery a hugely exciting area, and one of the other advantages of it is it really can lock in a stable electricity price going forward. So this is a typical savings chart for an industrial heat recovery client, and you can see that on a 10-year contract basis, and these are assets that probably have a 20-year life cycle, but on a 10-year contract basis we can generate savings of about £250,000 per annum. And when you factor in future electricity and carbon price projections, the real value of those savings could increase to as much as £400,000 each year. So huge potential savings to be had. It tells a great story and there's significant carbon benefits. So there's really a lot to like about industrial heat recovery, and we're excited about it as an offering. That's us kind of talked really about the financial business case for this stuff, but I think equally important going forward are the non-financial drivers, and there's a couple of key messages that we think are going to start to have an impact. The first of these is shown in this picture. So the kids are marching. There's strikes in schools today, people protesting against climate change. I don't think the fundamental drivers, even though it maybe feels like it's messy and complicated politically out there at the moment, I think there is a growing consensus about climate change and the need to really start to address carbon. And I think the next generations are even more attuned to that than we are. And what that will drive ultimately is increased corporate social responsibility. So I don't think it's going to be acceptable in the likes of the food and drink supply chain to sit as a kind of not doing anything about your carbon footprint. So I really genuinely think that these non-financial drivers are going to start to impact. And in government policy terms, the way they're going to make that real is through the SECR, which most people will now be familiar with and have their heads around. But the simplified energy and carbon reporting is going to start to be published in annual reports. There's going to be real metrics and real measurements there outlining how people are performing against carbon targets. And one of our colleagues from one of the TPIs summed this up really neatly to me by saying that it's the first time that he's walked into boardrooms and people are actually starting to think they've got to start delivering on these carbon savings because their customers are going to start expecting it of them. And I think a lot of people at senior board level have maybe believed the greenwash, they believed the propaganda about what they're doing for the environment as being helpful. So they've kind of convinced themselves that the fitting of some LED light bulbs is making a meaningful contribution. And what SECR is going to do is highlight how far people have got to go. And I think the best analogy for this is the emperor's new clothes. So there's a lot of people out there thinking that they're resplendent in their carbon saving finery, and when the numbers are written down are going to start to feel a little bit naked. We know that SECR is going to be hit more than 11,000 businesses, and it's going to be really interesting to see how many of them feel that they're on trajectory and doing a good job. And so I'm of the view that there's going to be 10,000 plus naked emperors out there. A little bit controversial perhaps, but let's see what happens. So what's this all telling us? It's really telling us that non-financial, we've spent the bulk of this talking about financial drivers, and that's appropriate because I'm yet to see many people fund projects or accepted a funded solution that leaves them financially worse off. But non-financial drivers are going to start to bite hard. And as Mark articulated, we really think that the volatility and the pressures that are faced in the electrical generation space will ultimately drive more decentralized energy and more on-site generation. And there are some current sweet spots that you can take advantage of and really get a good business case going. And please don't forget what I called the simple solutions. So decarbonisation of heat off the gas grids, biomass as a waste source. These are really strong business cases out there today. For some of the more complex ones, they do need to be assessed on a case-by-case basis. But we genuinely think that there is a strong and positive future for on-site generation. So that's the end of our kind of policy and financial business case piece. I'm just going to hand back to Mark, who's going to spend a couple of minutes talking through some real-life example case studies.
So we have two case studies that we wanted to share with you. The first is Villa Nursery, which is a 15-acre greenhouse, which formerly used to grow peppers. It now actually grows tomatoes. But it's a huge consumer of heat. And we supply that heat from essentially a hybrid installation. So on site we have a biomass CHP, we have a biomass boiler providing heat only, but we also have a peaking asset. So it runs for peak power principally between 4 and 7 when the distribution credits are greatest. And when it runs, the heat is recovered and it's caught within the water accumulators and is added to the heat store. So I think it's a good example of a joined-up project combining multiple different technologies and multiple different business models. And the benefits to the customer is in the form of a cost saving, a fairly substantial saving of circa £200,000 a year, and a reduction in CO2 of 1,800 tonnes a year. The second example we wanted to share with you is what we call centric power. This is an example of an urban reserve project. And here we approached the landlord, the owner of this large distribution depot, and the approach was around taking a few of his car parking spaces that were not otherwise being used. And on those car parking spaces, we have developed a peaking project. So that entails 2 megawatt engines, so 4 megawatts in total, providing power to the grid in the first instance. And we've deliberately targeted SSE as one of our core DNOs because the distribution credits are relatively attractive from connecting in at 11 kV. So this asset in the first instance will run between 4 and 7 during weekdays, and then outside of those windows will run during times of peak price volatility or system stress. Now, the interesting thing about this project is the landlord and his prospective tenants are very interested about the prospect of procuring heat and power from our installation. So ultimately, what we have is a gas reset that where we can recover the heat from the jackets and from the exhaust and supply the power via a private wire. And the potential tenants looking at this building want lots of power. And it is becoming increasingly hard to get power in this part of the country. The project is interesting, I think, from a couple of fronts. One, it's an opportunity for us to develop a peaking asset, but two, in time, hopefully we can sell power to our neighbour and recover the heat to make the system even more efficient. And the advantage to the customer would be obviously a reduced power bill and reduced heat bill. So I think that wraps up our presentation, and I guess we should open it up to the floor for questions.
Yes, that's right. Thank you very much, Mark, and thank you very much, Stuart. Lots of information there, which I hope has been very useful and insightful for those listening in today. So we'll swiftly move on to the Q&A session now, so we can make sure we can get through as many questions as possible. Since I've just looked at the time, we haven't got much time left. So first up, obviously we've been talking a lot about on-site solutions today, so it's quite interesting. If having an on-site solution is a good idea, why aren't companies funding it themselves? And why is AMP Clean Energy offering these fully funded solutions? Who'd like to take that, Stuart or Mark?
Will I kick off, Mark, and then hand it over to you? So, I mean, I think this is that in a nutshell is my daily challenge. So we do see huge benefits as we've outlined in these behind the meter projects, and I think what the problem from the customer's point of view is often that they are sitting as part of businesses that have competing priorities for capital investment. So we get quite excited when an energy project like this delivers a 5 or 6 year payback, because we think that that's great. We've got access to 20-year money, so we are able to fund them. But for the client, a 5 or 6 year payback's often not that exciting, no matter how good we think it is. So in many cases, they'll have a hurdle rate in capital that sees a 2 or 3 year investment. And there's always competing priorities, which are around investing in things that boost their production or their frontline service or whatever else. So really, I think capital availability has been a big barrier. And when you couple that with a little bit of technological uncertainty, that's fundamentally why we think there's a huge opportunity for us being able to fund these projects and just give people the carbon and the cost savings.
Okay, thanks, Stuart. Next question is, when is TCR going to be implemented? Who'd like to take that?
That's a very good question. I think the Minded 2 decision talks about 2020, 2021. However, there is the SECR is ongoing, and I think there's an increasing sense that it would make more sense if they were more joined up. The SECR, the outcome of the SECR might be that use of system charges and grid access comes into play in 2022, 2023. So I think, and I might not be correct, but I think as things currently stand, it's 2020 or 2021 for the TCR. But I think there's a growing sort of groundswell to push that back to match the SECR.
And it's probably, this is just another example, Mark, of confusing 3-letter acronyms. So I talked a bit about SECR in my presentation, which stands for...
Yes, and that's the other question about what does it stand for.
Okay. So there's SECR, which is the Simplified Energy and Carbon Reporting, and that is so some new rules that mean any organisation above a certain size, of which there's 11,500 in the UK, is going to need to fill in a report as part of their annual report every year, outlining how they're progressing the carbon intensity, basically, of their production process. So that's SECR, Simplified Energy and Carbon Reporting. But Mark, you're talking about SCR,
Indeed,
which is something different to SECR. It's probably worth just explaining what SCR is.
Yeah, sure. So this is a review, a strategic code review being undertaken by Ofgem. A significant code review, apologies, not a strategic code review. Significant code review being undertaken by Ofgem, and that's very much focused on the use of system charges and grid access, and how those charges, which may or may not be changed to account for the changing generation makeup and the increasing generation of distribution.
Okay, thank you both. Moving on swiftly to the next one. Is biomass as a technology still viable for large industrial users?
Good question. Yes, I think it is. I very much think it is. The reality as we sit here today is that we have 2 years and about 14 days left of renewable heat incentive. Who knows what's going to happen with that? It may be extended, it may be refocused, but the gestation period of a large biomass project is typically 3 to 6 months in business case and sign off, and then a year of build out. So I would say there's not that much more time to crack on and start to think about them. But yes, the business case can be viable, and in many cases remains the most significant way for an organisation to make a big decarbonisation step, because the advantages of biomass in terms of carbon footprint are absolutely massive for large industrial users.
Okay, thanks, Stuart. I think we've only got time for just one more now, and this might have to be quite quick as well. So this is about gas peaking plants. Are there any geographical hotspots that are more viable for gas peaking plants than others? So Stuart or Mark?
And Mark?
Yeah, I'll probably take that. Our focus is very much in the south, the southeast, around Greater Manchester and Greater Liverpool, because that's where currently the distribution credits from connecting at 11 kV is greatest. But also, these are areas where we anticipate demand constraint to be greatest in the future. They're in areas of relatively high population density. It's where we anticipate that, the greatest growth in terms of demand users connecting for EVs, for heat pumps, and that's where we think long term we can add the greatest value.
Okay, thank you for that. Unfortunately, we're running out of time now, so I'll have to wrap this up. But as mentioned earlier, you do have the option of listening into this webinar again. After the session is over, we'll be tweeting out the link. And obviously, for those of you who have any follow-up questions or who'd like to get in touch with Stuart or Mark about anything that was discussed today, the details should be on the screen. So Stuart has kindly provided his mobile number. It should be on the screen, 078-33231-085. Or you can send him an email, which is Stuart with a Stuart.reid, R-E-I-D, at ampplc.co.uk. So all those details should be on your screen right now. So you can either drop him an email or give him a call. So feel free to please share the webinar later on with your colleagues who you think might benefit from the information that was provided today. Or if you'd like to watch it again, you can do so after this has been recorded, so after midday today. Also, please do not forget to rate the webinar and do leave us a comment. We'd love to know your thoughts. And at Energy Live News, we're always looking for interesting stories about businesses installing these on-site generation technologies or other energy efficient technologies that's helped them save money in the long run. So do send them over to stories@energylivenews.com. And also, if you have anything exciting that you're installing, you'd like us to come and film, please feel free to send us an email as well. And finally, before we sign off, I'd just like to get some final thoughts from our speakers. So very quickly, Mark, would you like to say anything?
Well, firstly, Pri, thank you very much for inviting us to do this webinar. I think, the market is particularly disruptive at the moment. There's a lot of unpredictability, but equally that creates opportunity. And so as things stand for us as a business, we see the next few years as a very exciting time.
Okay, and Stuart, anything you'd like to add?
No, just thanks everybody for joining us and listening to what we have to say. And I think the future is positive. There's some complexity in the system right now, but the future for on-site generation is positive. And we're happy to work with any business that wants to save carbon and cut costs.
Okay, thank you both. As mentioned earlier, we couldn't get through all the questions, so feel free to get in touch, or alternatively, we can try and get in touch with you. You also have access to this PowerPoint presentation on your BrightTalk account. We'll be tweeting it out. Thank you to both our speakers, Mark and Stuart, and thank you to everyone who's joined us today. I hope you all have a great week. Thanks. Bye.